A very important inequality is called the triangle inequality. If we have two complex numbers, set 1 and set 2, then the absolute value of the sum is always less or equal to the absolute value of the first or one of the complex numbers multiplied added with the other absolute value. So this is an important inequality, and it's possible to show this by some geometrical visual proof, so to speak. This is set, if you have set 1, this vector is set 1 and this is set 2, then these two vectors can be associated to each other, and the sum of them are possible to express visually, so that we see this inequality. The best way of proving this inequality is by direct mathematical manipulations. We are not going to go into details here, but a more general expression or inequality is like this. We have the sum of n different complex numbers, and we take the absolute value of it, and this will always be less than or equal to the sum of the absolute value of each of these complex numbers. Another reversed triangle inequality is like this. It's the absolute value of the first, or let's call it set 1, the absolute value of set 1 minus the absolute value of set 2. This absolute value is always less than the absolute value of the sum of these two complex numbers. And the third part, or the second part of this inequality we have written here, is just the triangle inequality. So, and this is also possible to prove mathematically. We are not going to go into the details at this point. Here is some exercise which shows the benefit of these inequalities. Let's show that, or let's start with stating that the absolute value of set is equal to 1. This is just for this situation. We are on a circle with center at 0 and with radius equal to 1, and we want to show that the absolute value of this expression is always less than 3, and that the absolute value of this expression is larger than 1. Let's do it. We note that the absolute value of these three terms is always less than or equal to the absolute value, the sum of the absolute value of each of these terms, which we are indicating here. And the absolute value of set square is always equal to the absolute value of set square. And the absolute value of set was stated in the start that it was equal to 1. So we have 1 here, we have 1 here, and of course we have 1 here. So we obtain that this certainly is less than 3, or equal to 3. So now we have proved the first inequality. let's go into the second inequality. We have that absolute value of z square minus 3. What's that? Well, now we go into the reversed triangle inequality. Let's go back to it. Which was this. This was the reversed triangle inequality. And we know that if we take the sum of set in the exponent of 3 plus minus 2, then this should be larger than absolute value of the difference between the absolute value of the first complex number minus the absolute value of the second. So what we are doing now is writing this guy as the absolute value of set in the power of 3, which we have done here. And now we are then in the position to state what this number is, because absolute value of set is equal to 1, so we have now 1 in the power of 3, which is certainly 1, minus 2. And the absolute value of this guy is just 1. So hence we have proven that the absolute value of set in the power of 3 minus 2 is larger than 1. I know that this may come as is not so easy for the students to understand as other things in complex analysis, but we are going to use this a little bit later in the course.